The equation of the mass flow rate and calculating it in this way often assists us in diagnosing and fault finding our heating system. The actual equation is given as the function of the boiler heat output in kilowatt divided by the specific heat capacity of water, which is a constant and its figure is 4.2, multiplied by the temperature rise, sometimes referred to as the differential temperature. Now notice that the boiler heat output is effectively the boiler heat input less our losses. The 60 factor of 60, which has been multiplied on top there, is simply done so that we can actually achieve our flow rate in liters per minute as opposed to liters per second. Now we could actually rearrange this equation in order to find out any individual element that's given in that equation. So long as we have 2 bits of information within that equation, we should be able to work out the third element by simply rearranging the equation. So let's have a look at see how that's actually done. So here we can see the original equation of the mass flow rate rearranged so that we can actually find out individual elements within the equation. On top line here, you can see that rearranging the original equation, given that we know the power rating of the boiler, and given that we know our flow rate, we should be able to work out our temperature rise or differential temperature. Similarly with this bottom equation, if we know our flow rate and we also know our temperature rise or differential temperature, we should be able to work backwards and find and work out the power rating of our boiler too. So I think here's a good time now to try to tie all this together in an example, and we should be able to work out from there on how to use this, I would probably say, a pretty fundamental calculation in our future fault finding and maybe even diagnosing any possible issues that we might encounter when we have a look at a heating system. So here are parameters given in this particular practical example. We are going to assume a 10 degree C as our incoming cold supply. We want to achieve 45 degrees at the draw off point, effectively giving us a temperature rise of 35 degrees. We're also going to assume the power rating of the boiler to be at 24 kilowatts. So to put all this information into the equation of the mass flow rate and to trying to find out what is actually our flow rate given all these parameters, we should be able to see that from our equation we have a kilowatt rating of the boiler divided by the heat capacity, the specific heat capacity of water, which is 4.2, multiply by our temperature rise or differential temperature. The 60 goes here in order to be able to achieve the result in liters per minute. So working that out, you should be able to get 1440 divided by 147. This in effect will give us a flow rate of 9.8 liters per minute. So simple enough workout to do. All you have to do is to replace the variables for the information given and work out what your flow rate is. So now that we've got all this information, we can actually go and check to see if the flow rate at the boiler, at the draw-off point, equates to kind of 9.8 or thereabout, given that all the parameters of our boiler and the actual cold and hot water is as given in this example. What we'll do is we'll be able to sort of look at various scenarios and finding out how this information can come useful in checking various points. Say, for instance, if we've got poor circulation throughout our heat exchanger, through our plate heat exchanger, or maybe even poor circulation because the pump itself maybe can't deliver as it should. It's simple enough to work out through the theory as to what the figures should be, and soon determine as to perhaps or pinpoint where the fault might actually lie. So until the next videos that we'll be looking at those kind of scenarios, thank you very much for listening.